Hi there. So my clock is currently running, but I'm getting a problem with friction, as I mentioned in my last video. There's too much friction in the bearings, and that's preventing me from putting in the great wheel at the bottom here. So what I'm going to do is test out a whole bunch of different types of bearings and see what works best. And here are the different bearings that I'm going to try out. So the ones that are currently in the clock, these steel ball race type bearings in a couple of different sizes. I'm also going to look at some non-traditional stuff. So we've got the plastic bearings and the more traditional bronze bushings. And then I'm using either steel BBs, so steel spheres, or this little sapphire window as end caps to the bearings. Here are some ruby bearings, which I'm going to try out, and also micro ceramics in 2 different sizes. So we'll give them a shot and see how they do. They'll all get mounted into this test frame. This is one side of it. So the different bearings get mounted in here, and then we'll swing a pendulum from those bearings and see how it does. Because I don't have a small metalworking lathe, I'm also using these quick pivots, and they have a cup on one side and a pin on the other. So that lets me just fit the cup onto a shaft, and that gets me back to being able to use a more traditional steel pin running in a brass or a bronze bushing. It lets me do that without having access to a lathe. So that's the setup, that's what we're going to try. We'll swing all these different candidates and see what the results are. And here are the details of the various bearings that I'm testing. Here's the test rig that I've set up. So we've got the different bearings sitting in the top, and there's a pendulum suspended from that arbor, and I'll swing the pendulum and then count the number of swings to go from a defined starting amplitude to a defined finishing amplitude. And what I'm doing is using the same beam break photosensor that I use for the pendulum timing on the clock. So from the start, which will be consistent, the beam break will detect the swinging of the pendulum until it reduces enough that it fails to break the beam, and it just counts those swings. So we'll do that for all of these pendulums, all of these bearings, and we'll see how it goes. So now we have some results. And the summary is that all of this type of bearing, the traditional ones where there's a pinion running in a brass or a bronze bushing, all of those were outperformed by the bearing style, whether it was bearings with steel ball bearings inside or these ones with the micro ceramics. The best of the bearings was this little one, F682. So for these, we found that the smaller internal diameter, the better. So the small bearings performed better than the bearings with the larger diameters. So this was the best of them. All of these traditional type, where you've got metal rubbing on metal, or even the plastic ones, they achieved about 40 to 60 swings of the pendulum before it reached my defined endpoint. The best of that style was the synthetic ruby, the olive ruby ring jewel with the synthetic sapphire end cap, and that got 75 swings from the Pendulum. But all of those were blown away, and there they are at the left. All of these were blown away by the bearing style. Here's the ceramics and here's the steel. And this one's the F682 that got the best result. So whereas these metal on metal style are getting maybe 50, maybe 60, this one got 450 swings of the pendulum before it reached the end point. So there's a dramatic difference. These ones here, I was curious about because they haven't performed as well as these ones over here. But it turns out this F684 and the SFRZZ, here they are here. And actually, now that I've taken them out, I see there's damage to each one. There's damage to each one. So at some point, when I was installing these, I managed to damage them. So that's why they've got such low results. I was curious about this dip in the results for the best performing bearing. Sometimes when it's properly set up, it performs admirably. Other times it didn't. I suspect that perhaps there was a shoulder rub going on here, but unfortunately this little bearing, there it is, this little bearing, at some point its partner fell out of my test frame and has disappeared into the dark corners of the garage or inside the dust collector. So I can't rerun the tests to see what is going on. But it does demonstrate that when it's properly set up, it does perform very well and dramatically better than any of the bushing style. But it's very clear that the bearing style gives a much higher performance than the bushing style. And now I'll close out this video and leave you with the graph of the test results. I hope you found this interesting and perhaps useful if you're contemplating bearings to use in your own clock. Thanks for watching. I'll see you in the next one.